This video is going to go through the IVT and the MVT, and an example of each and how you'll know when to use which one. The first question is about the IVT. I've got a table of values of h, and I'm told h is differentiable, and I'm looking for where h of x equals -3, or is there a value between -2 and 1, which is the entire table, where h of x equals -3. So one thing that I'm noticing is that I'm asked for an h of x value, and in my table is h of x. If there's a match between those two items, then I'm going to look to use the IVT. And just looking ahead to the MVT problem down here, what I see is I'm being asked where h prime is 5, and I've got in front of me a table that has h. So the fact that this one has the derivative value tells me that I'm going to use an MVT down here. So the top one's an IVT and the bottom one's an MVT. In order to use the IVT, I first need to have a continuous function, and all I know is that it is differentiable, but we know that any differentiable function must first be continuous. So I'm going to start by saying that, and you have to say this on your paper. Since h of x is differentiable, it must be continuous. And you've laid out the condition necessary to use the IVT. I know I'm going to use it, so I'm going to go ahead and mention that now. So the IVT applies. What you have to do when you use the IVT is you have to look at the value you're trying to prove. So I'm looking at this -3. And -3 has to fall within one of these subintervals. If you think about it, it makes perfect sense. Because if I just graph this out real quick. Sorry, this is an ugly graph. So if I have -2, -5 is here, and -1, 0 is here. What the IVT says is if this graph is going to go from a y value of -5 to a y value of 0, if it's going to go from here to here, I have to bypass all of these y values in between, and -3 just happens to be one of them. So I know that I'm going to hit -3 on this interval because -3 falls between these two values right here. On my paper, I need to acknowledge that. So part of my justification and my explanation over here is to take that -3 and position it between these two values right here. And you can say it just like that, or you can use function notation. So it would be okay if you wrote h of -2 is less than -3 is less than h of -1. So you could use either or of these. And pretty much that's it. You have identified the interval on which this function will take on the value of -3. So now I'm just going to sum it up, and I'm pretty much just restating the question. So there is an x on, and I know that interval is going to be between -2 and -1. So I'm going to say -2, -1, where h of x equals -3. So the important parts of this, you have to say you have a continuous function, and you know that because it's differentiable. Mention IVT, position that number in question between two of the y values, wherever it applies, and then just summarize the question and specify that interval that you found in your table. So on to the MVT, and like I said before, I know I'm going to use an MVT if I see this is the derivative of what's sitting in the table. So IVT isn't going to apply, but it's a clue that MVT will. The conditions for an MVT are differentiable and continuous function. So I'm going to first start by saying that. Since h of x is differentiable, it is also continuous. So the MVT applies. And what the MVT says is, if I can find in my table, if I can find a place where the average rate of change, and just a reminder of what average rate of change is, h of b minus h of a over b minus a. And I used h because that's the name of this function here. So if I could find some place, some interval on here where the average rate of change equals 5, the MVT says there is a place where the instantaneous rate of change, also known as h prime, will also equal 5. So I'm just going to look at different intervals in this table, and I'm going to do an average rate of change, and I'm looking for an answer of 5. And this takes a little bit of playing around. I can consider the table as a whole. And so what's kind of going through my head is, if I do 4 minus negative 5 over 1 minus negative 2, I get 9 over 3. I'm trying to get a value of 5, so that's not my interval. So then I look for something else. So I might look at this interval right here. So that would be 4 minus 3 over 1 minus 0. Again, that's not 5, so that's not my interval. And I just kind of play around with the different intervals until I find it. And now when I look at this interval right here, I get 0 minus negative 5 over negative 1 minus negative 2, and that becomes 5 over 1, which is 5. So I found a place where that average rate of change equals 5, so I know there's an instantaneous rate of change that will equal 5 within that given interval right here. So now I've found it. Now I just need to sum it up. So I would say, since there is an average rate of change equal to 5 on the interval from negative 2 to negative 1, by the MVT, there is an x where the instantaneous, okay, I can't spell, but it's okay, rate of change equals 5. And when I say instantaneous rate of change, that is just my h prime of x equals 5. And your wording can vary from what I have here, but the important part's saying that you have a differentiable and a continuous function. So making that assumption right there, and mentioning the MVT, showing me an average rate of change, and you can do it in function notation if you want to. So in place of this right here, I could have said h of negative 1 minus h of negative 2 over negative 1 minus negative 2. But somewhere you have to say it either in this format or this format. And then just a sentence kind of summing it up. You know, I got an average rate of change of 5, so I know there's going to be an instantaneous rate of change of 5. And that's pretty much it. I hope this helps.